Everybody, I hope you're doing fine. Had a nice weekend and back from all the excursions over the weekend. Today we talk about big data and stocks and flows as important components for the smart city of the future. Question at the beginning, how's it going with the exercises? Exercise number 1. We have 15 people here. 13 of you have handed it in. So there's still a couple of you, if you are the same ones, that have to hand it in. That's one thing. And the other thing, I wanted to know how it's going with the groups out there, with the other people taking the MOOC. Who is already corresponding or in the discussion groups of you? Can you just quickly raise your hands? Who is doing something with these groups out there? Reading? No, you have to get into it, you know. You really have to read and write. This is so important. Otherwise, it becomes passive. Really, go in there, look what they've written, give your answers, or make your proposals. That's very, very important now. Because then you can also see what's on the mind of these people taking the course from outside, and it gives you a good idea of what you might want to ask. Now, let's start. This is already the third lecture here, and as I said, urban big data and stocks and flows in urban systems is the main topic. And the story so far, we started with the cities as complex systems. Then last time we had the smart houses and the transformation to smart cities. And today it will be big data as new urban raw material and made useful with information architecture and with the stocks and flows concept. Can you imagine what that means? Any one of you can imagine what it means? Doesn't look like it. I hope by the end of the lecture you will. So big data. For you, it should be something normal because everybody is talking about it. But the definition is still ongoing. And if we look at one particular aspect of big data, take this year, as we are here now, there's about more than twice the world's population in number in the form of Internet of Things, little devices, computers, chips, all other things that can communicate with each other, that are deployed all over the world, and that produce data of any kind. So they routinely record all kinds of things like weather data that we will look into later, but also where you are, what you do, where you go, all of these things. And this is going on now. So this is an incredible amount of data which is being produced. They can be recorded, and they are recorded, and they can be analyzed with increasing ease. You probably have heard of user profiles, you have heard of all kinds of Facebook profiles and so on, which you can make if you want to, but you can also watch how other people are taking your data and make a profile of you out of this. So each one of you, of us, of me, has one or more or hundreds maybe of digital identities, which is separate from your real identity, or becomes an extension of your real identity or your physical identity. And with that, people start to do business, but they also do to try to fight crime, of course, and other things. But these data that we are particularly interested in, of course, is the cities, the urban data, and the people in those urban data. And this becomes then a new raw material, because if you have these data, you can make new things out of it. You can put it together. If you remember last week's lecture, you can put together data into information and then information into knowledge. The age of big data, and especially the recording and analysis of big data, is offering more and more an alternative, because it seems that no longer you need to put together information out of data on which you define relations. it looks more and more that you can use automated algorithms that make these relations automatically. So taking the human out of the loop. And I will show you, that was a proposal from you last week, more examples. So I will show you two examples, one from Zurich and one from Songdo in Korea, how these two ways of creating big data are working. The big data are the so-called 4 V's: volume, variety, velocity, and veracity. And the volume is, of course, that is very, very big amounts of data. In the old days, they said everything that doesn't fit on a spreadsheet is big data, but that was rather a harmless description of it. Today, we have gigabytes, petabytes of data that are handled in data sets for big data analysis. There's our own field, our own science has become of it, the data sciences, and data analytics as a field dealing specifically with extracting knowledge and information from data. The second V is the variety, so it's diverse types of data, all kinds of behavior data, weather data, transportation data. You can just all throw them together. So it's very, very diverse sources and also types. And the reliability and the quality of each one of these sources is, of course, very different. Velocity, that is that just the amount of data is increasing very, very rapidly. The data volume is expanding exponentially at the moment, of course, related to the first point. And veracity, that is quite an important point, because veracity is a certain type of insecurity regarding the quality and the meaning of these data, both when you record it and also when you have the results of data analytics. You cannot be entirely sure if that's what the data really mean or could mean. So with these 4 V, you get quite far, and I just propose that you look into your surroundings and try to observe where big data or data about you is collected, or where you donate data to somebody else, or where you receive data from somebody else. So the first case study I want to present very quickly, a few images only, but to make you aware of what is happening there, is when you record big data mainly from observations, from measurements and observations. And remember last time I showed you this one slide with this room with hundreds of screens in it? That was the control center of Songdo in Korea. And also Songdo has been extensively written about, advertised a lot, and the smart city of the future will bring big data to a new level. This connects our two topics today, big data and the city of the future. And this is, of course, not Songdo. This is another city. But Songdo, they wanted it to make completely digital. And they said it will be a revolution in city design. It's south of Seoul in Korea and very close to the Incheon airport, so you can get there very quickly. And they write Songdo will become a completely connected city where almost any device, Internet of Things, building or road will be equipped with wireless sensors or microchips. This will result in smart innovations such as streetlights that automatically adjust to the number of people out on the street. All houses in Songdo will be equipped with sensors, also known as domotica, which can be managed via a large TV in the living room of each residency. Next to the homes, these telepresence screens will be available in all offices, hospitals, schools, and shopping centers. The city of Songdo is a futuristic city completely ready in 2015. Who was there recently in Songdo? Nobody. Well, I was, but it's not ready. Some of it is ready, and if you can look at it, what is ready. But you read already, this smart buildings, which we talked about last time, is popping up here again. So there's a strong relation between smart buildings and smart cities. That's how the city started. In 1995, there was nothing. It was a land, like between the sea and the land, a piece of coast, very, very flat, which was covered by water, slick, mud. Then they started to fill in that land. So by 2001, you see the land infill going piece by piece ahead. By 2005, the first buildings had emerged there. And 2016, from one particular angle, it looks like this. So it's really a city built from scratch. And they decided to have, while they built it, everything wired as they wrote, sensors, road networks, and so on. And you can imagine it's kind of foggy here quite often. Seoul is up in this direction. Then there's a little mountain range in between. But then you have this developing land here, which is all being wired. And if you're in one of the towers, you can see how it goes down. You go down the tower. You see this extensive transportation networks, of course. You see the new buildings being constructed next door. And you can see a lot of construction, a mix between completed and not completed parts of the city. The Gale Corporation that you see here is the developer of this whole thing. And Cisco, the networking company, was one of the original companies who promoted and also invested in this city. But there is not much that people can do about it. They are being recorded, observed, their cars, everything they do, but they have very little input. They can choose from those screens, but not much more. But it's all taken from data that are measured in real time. Another way of looking at big data or creating big data is when you create it really from models or from simulations. And here the city of Zurich and GIS Zurich under Gerhard Schrotter, who did these movies, you might get a glimpse of that here. This is the city of Lucerne. And you can see how the different people or cars are moving in a city. Here you have a little legend, and it says what the people do. They go to work, or they go to shopping, or free time, and others. But you can see how they move through the city. Interestingly enough, you wouldn't be able to tell, is it a simulation or is it a recording? What do you think? Is it a simulation or actually measurement, recording?
If it's recording, how did he track them?
Pardon?
How did he track those people?
If it's recording, how do they track the people? Good question. What would it require? Yeah, that would be one way, yes. Or?
Cars, maybe.
Cars, yeah.
Yes.
GPS, right? Or?
But if it was GPS, you would have to know where they don't tell you usually by GPS what's their destination.
And what they are up to, right? So that's very good observations. And the other part they could also use, what you saw in Songdo, is just cameras all over. So cameras which recognize license plate, car types, and so on. But again, from this they could hardly make those deductions here. So, but if you have a simulation and you create an artificial person, like you will see at the very end, you can actually give a certain schedule to each one of these people. You have this service in the city where you ask, where do you live, how many children do you have, what is your income, and so on, the Volkszählung. Where do you work, what do you work? And then you can start to connect these data with the actual work data that the city also has. So that's a combination of generated data and simulated data. So this is a simulation. If you look at that one, also from the same city of Lucerne, this is now clearly a simulation because, to my knowledge, this did not occur in the last years. If you look what should happen here is now. You see the the water level is rising in the lake here in the Vierwaldstätter See, through whatever reasons that could be, maybe an avalanche or something happened. And now you see how the water is creeping up into the city of Luzern. This is the train station here. This is, of course, the concert hall. And you can see that after a while, almost this whole part of the city is inundated in water. And this is by rising levels of 2 meters. This you see also on many Google Maps. You can simulate this in coastlines of the cities in the world, but this is clearly a simulation. You take the existing GIS model and you have a dynamic process, water rising, and then you can show which city parts would be flooded and which ones not. Of course, you could do, when you had the big storm of Katrina in New Orleans, you could have recorded this also and then compared it with the GIS model. It wouldn't have helped at this time, but it would help for the future, because in this way you can calibrate these simulations and then you know what would happen really if a flood, a fire, or whatever would happen. So here you create a lot of data from the simulation. And there are many other parts of simulations or applications in the city. And here we can have a glimpse into it. This is GIS from the city of Zurich.
Digitale Karten und Pläne, sogenannte Geodaten, sind eine wichtige Grundlage für viele Aufgaben in der Stadtverwaltung Zürich. Zu diesen Daten zählen zum Beispiel der Zonenplan, der Lärmkataster oder das Geländemodell. Diverse Dienstabteilungen.
So, this one I wanted to look at in particular. This one, for example, this is the zoning plan, which is very important, and it's overlaid, as you can see, on a map of the city. And this zoning plan, of course, defines what kind of zone that is, what you can do in this zone, and this is a very important semantic information you can get from the city. So it's not data that you read from the city or from reality, but that's data or rules that you impose before you actually build. And I want you really to see this difference, okay? The next one, when they move here to the one with the noise, the before? Tricky. Okay, let it go. And maybe perhaps it has loaded the rest of the simulation now, I hope.
Digitale Karten und Pläne, sogenannte Geodaten, sind eine wichtige Grundlage für viele Aufgaben in der Stadtverwaltung Zürich. Zu diesen Daten zählen zum Beispiel der Zonenplan, der Lärm.
Anyway, the noise plan that you saw, it could be measured again, or it could be simulated. Most likely, it's been simulated from the measurement of the cars, or has been simulated from the simulation of the cars going through the city. So you have all kinds of interaction between simulation, measurements, sensor-read data, and then visualization that you see here. The point is, when you look at the result, you cannot always tell what it is or how it was created. But I just want to make sure you know that there's a difference, and then after a while you get a feeling for it, if it's real data or if it's simulated data. And the last part, maybe that will work. We will run really total simulation only. And that shows again this intermix between reality and measure data. Now look at the plan, the real plan, then they put the iPad on top of it, generate a 3D model of this. This 3D model itself could generate a lot of data that you could use then for people having experiments in this virtual environment here. And then it would become suddenly real measured data in a virtual environment created by simulation. Estefania, see, this is what I mean. It doesn't continue. Sometimes have to wait a while. So you can also use the model here of a new site. You put your iPad on top of it, and then you just give different opportunities or different solutions or different proposals for this site. Have you used that already? You don't have one of those? No? Go back one. I want to go to the very last point of this video. Let me see. Maybe I do it by hand. This is easier. So these are the different options you have. And how is it done? You have a so-called marker on the model. You have a so-called marker, an optical marker. It could be this one here, it could be this, it could be this, it could be anything. And that marker links the camera of the iPad directly to this model. And then from this, depending how you move around with the camera, you always look at the same angle at this model and the projected model on the camera. So by doing this, again, you're producing a lot of data, because if you look at this now and you would equip that person looking at this and measure her or his brain waves, you could immediately see, does the person like this or not? Or if you put up your glasses and walk through virtual environment, you can make these measurements, although the environments are totally virtual and just made by simulation. And then this I find particularly important, and this is pure information architecture, because this is pure information architecture because now you can walk through the city, you can also use certain markers, and then you can make the invisible visible. Remember, that was one of the definitions of information architecture. Make the invisible visible, and what you see there? Nothing? What do you see?
Pipes.
The pipes. Yeah, exactly. So the pipes, you can exactly see the pipes under the ground, which is so important, because imagine if you want to open up the street, or you have to open up the street. Without this, it would be just terrible. Actually, it would be like it most of the time is, that you have to dig huge holes and you don't find what you're looking for. So for that, these data, these simulated data, are very important. So this is a combination of simulated data and data taken actually from the environment. And this is particularly cute because with that one you can go back in history, and this is obviously a simulation, it's not from real data, but you can see how this Pfahldorf, the little village that was in the place where Zurich is today, might have looked like many hundreds or 2,000 years ago. So these are some of the applications of big data, and big data taken from observations, and big data generated with simulations. Now, this is very useful for our work in Singapore and for urban planning, because we know that in the next 30 years, 2 billion people have to move into cities that might not even exist yet. And of course, we don't want to repeat the problems of the past. And the more we know about how cities developed and how people behaved in the past, the more or the better we hope we can make the future cities. We use for that the so-called stocks and flows model as one possibility. And this stocks and flows model goes back many, many years, decades. One of the early ones you see here, that you have the human habitat. That could be a house, it could be a village, or it could be a whole city. and you have input coming into the house, food, energy, and goods, or in the village or in the city. And then you have output, you have the waste, inorganic waste, organic waste, that somehow disappears, used to disappear. Because the villages, the cities of the past, they were so small, and there were just a few. So that was the normal way of doing it. But today, we have to do much more recycling, because otherwise, this part here, this output part, is toxic, takes lots of space, makes people sick, and nobody wants to deal with it. So this is the reason why we have to consider not only the flows in and out of a city, but the stocks and the flows. And in this, we can call the urban metabolism. So the city is like something like a creature, or something like an organism that has a certain metabolism. This is an analogy, of course, only not a real organism. So with that, we can understand the city behavior as a dynamic and complex system. That's what we started out with. That was our first observation of a city. But now we can read and model the city in terms of stocks and flows, and use these stocks and the flows as dynamic elements of the urban metabolism. Those of you who come from the economic part of the world, or look into economics or study economics, they will know this principle since many years. So you have this stock of money. In this part, it's flowing down. The stock of money, it's flowing down. So this is the flow. Another intermediate stock of capital, and from there it might flow away again. So if you just look into your wallet, I think you can understand this quite well. Although the stock and flow in your wallet is probably going back a lot compared to earlier times when you had little pieces of gold or something. You had to get from somebody, physically put it in your bag, keep it. That was the stock of capital, and then you gave it to somebody. That was the flow again. And this way, you had the whole economy going. Now, you can apply this principle to many other things. You can apply it, most importantly, to people, because people and health, this is a great stock and flow. Like now we have a little stock of 15 people in here, and then when you go out, you become a flow again. You assemble somewhere else in different configurations. So this is what actually these simulations are measuring and recording, a stock and flow of people that you saw before. Stock and flow of water and capital is very easy. The water, it becomes a stock when it freezes, like in this lake, or it becomes a stock when it's sitting somewhere in a reservoir. But there's always some flow, so this is never totally calm, a piece of water or whatever, a piece of capital. The stocks and flows of energy and materials are very, very important today. You know that most of the countries have signed the Paris Agreement 2 years ago to reduce the CO2 output, greenhouse gas output. And of course, that stock of greenhouse gases, or the elements of greenhouse gases in the earth, is supposed to stay there and not go into the atmosphere, where it will then cause a lot of changes in the world. So that is a very, very strong stock and flow, energy and materials, of course, as well. The city of Pompeii was totally destroyed. As you remember, it was as a flow of lava coming on top of it. Now they removed the lava again, and the original structures come out again. Stocks and flows of energy and material can also be in a more peaceful way, like this one, this building construction that we have in the Zurich city. You can see wood and concrete in harmony, living together to make this new media building here. And so the stock of wood is at the same time also a stock of CO2, because CO2 is embedded in this wood already and will be sitting there until the wood is decaying or being burned. And this stock and flow of energy and material is a very, very old story. So this is an old painting from a monastery in Naples, and you can see how the stocks and flow of the ideas was translated in the stocks and flow of the material, the monks bringing it and the water and bringing it to the construction site of the monastery and then actually building it. So this is an architectural or urban stock and flow example. And space and density are also important stocks and flows. Transportation and information. We saw the transportation example from Zurich before. And here is an information stock and flow example from our Value Lab downstairs from the early days. Here we can see, does somebody recognize that shape of the landscape in the back? The people here from Zurich? Anyone from Zurich? No? From Switzerland? Yeah, you must recognize this. Has been in the media so much. This is for your testing your shape recognition as architect. Yeah?
The shape
Yeah.
seems familiar, but the buildings are too small for it.
Which shape?
Green City, but the buildings are too small.
Ah, see, this is now big data from simulation. No, it's Dübendorf. It's the airfield of Dübendorf. It was the old military airfield, and the idea was, or is, to transform that into a techno park. And so we used, our students, your colleagues from a few years ago, used shape rules that they got from put into the City Engine program and generated a whole city on this airfield of Dübendorf to do all the functions that were asked to be done there, research, testing, and so on. And so you can generate big data out of information, stocks and flows of information. Now we come to a very important, how should I say? It's a departure point. Because with this big data that you read in the press and that we have talked about a little bit today, we get into a real area of ethical questions. And the Swiss Academy of Technical Sciences, SATW, has put together a group of experts that have looked into the ethical aspects of big data. And this is really, really crucial. No matter what country you come from, in the future, those things here will be looked at very, very deeply. And besides the 4 V I defined at the beginning, these will be, at least those will be the points we have to be very careful about. And it will decide on how big data will be accepted or can be used in the future. So the point 1 is the protection of privacy. You hear a lot about this, but if you don't actively do something about it, there will be no protection of privacy. You cannot always rely on others, on laws, and so on to do that, because for these areas of big data, many laws do not even exist. So people can gather all kinds of data without protecting your privacy. Not intentionally, but it can happen. The second point is equality and non-discrimination. No monopolies. That means that you cannot just collect data on people and then single out individual people, make profiles on them, and then follow them up. For example, for elections or for marketing certain things. That's happening to you already, I think, when you do something on the internet. There's a profile of you being constructed, and they do this. And if one company would have a monopoly on that, then that would be really, everything else would just fall apart. The third point is personal decision on data use, and an agreement is necessary if somebody else wants to use your data. Some of the websites you're using, they ask you this every time, if you really want to do that, but if you cannot, you forget about it, and next time you donate all kinds of other data. The fourth point is the control over the own identity, digital identity, and that you are able to do the corrections. You are too young to know probably that in Germany, for example, in East Germany, there was this big organization that did recordings on almost every person. They wrote down, they did, spying on every person. People spied on each other, and they make a lot of Fichen, as they call it, recordings. And after the end of the state, the East German state, all of these documents were found. Nobody knew what to do with them. But then people discovered they had created another identity of them. At least at this time, they could have seen what other people had written or said about them, because it was still on paper. In this case, it's much harder to do that. The same thing happened in Switzerland to a lesser degree, and I'm sure in many other countries it also happens. So if somebody has a constructed identity of you, and you cannot even correct it, let alone see it, this is really, really a big problem. Then transparency, especially concerning the algorithms. If you have now, these days, these machine learning algorithms that do detect from your behavior, from your pattern of movement around a certain way that you live or want to live. Do you know about these algorithms? Most likely not. I mean, you're doing in these other courses, if you do them, digital urban simulation, you do all kinds of experiments, how to use data, how to analyze data. But these algorithms, they go much further, and it's very hard. On top of it, they are trade secrets of the companies who make them. So they're like black boxes. Solidarity, especially in insurances, is a very big theme, because insurances, all companies collect data on you, and of course they want to make money. Then of course they have to single out people who are maybe more sick than others, and this idea of all the people in a country or in a group carrying each other's loads in terms of insurance costs, or in terms, not insurance, but health costs, could be destroyed by that. So in the end, you would have really not a two-class society, but many classes. And if you are born with some disease or something, you would be singled out from the very beginning, and you can never get insurance, and probably would just have a very bad time or even die. Contextual integrity, especially business-private. You hear and will see a lot about this, but as everybody is suddenly on one medium and data is freely exchangeable, your private behavior, your private pictures, all of this can be used for you. Of course, you want to use it for yourself, share it with your friends, but it also could be used against you. So what do you do this? You have to really respect the context in which these data were gathered in order not to use them against you. And finally, the ownership and intellectual property of data. This is what we keep saying again and again for the responsive city. You, as a citizen, have to have the right to define if you want to give away this data or not, and who should get this data or not. Because you are the person, so you are the owner of this data. So these 8 points, they might change over time, but in principle, they will stay. Maybe one or two others will come to it. But always think about them. It's very important. Now, in the pre-big data time in, let's say, 10 years ago, when we started the ETH Future Cities Lab in Singapore, to give you a better understanding of these stocks and flows that we were talking about, in each one of these stocks and flows, we need a lot of data. So actually, this simulation platform that you see here at the bottom, this was the data collector for all of these other stocks and flows: space, energy, material, people, capital, water, and information. So in this information platform, everybody could put their data into. It would be maintained, and then other people could use these data to do useful things with it. But in creating this simulation platform, we took very much care that we respected these rules that you saw before. It was not so difficult because at this time there was not so much data just generated from phone calls or whatever. And now if you connect it to architecture, and you can see some of these stocks and flows, just to give you a more graphical example. Stocks and flows of energy. Of course, that thing, I mean, I can feel it here standing in front of this wall. You know, this is just radiating heat. I can feel it. But if you walk through a street in Singapore, it is extremely hot because of the air being ejected from the buildings into the street. But here, this is also fake, as you can imagine, because the buildings are very close to each other, but they're not overlapping. So somebody photoshopped that. But the stocks and flows of energy, understanding them enabled us to do this test building in Singapore, the United World College, and to build a construction that is different from the constructions, the other office buildings in Singapore, that actually uses 60 to 70% less electricity and therefore generates less heat, less noise than all of the other office buildings in Singapore. Considering stocks and flows of energy, you can do great things with it. Or this one here, this was the origin of the big robotics building you see over there now, Komatsu and Kohler, testing on smaller machines in Singapore, building high-rises and so on, and then building this huge construction here. Stocks and flows of material, of course. Stocks and flows of material, you just go to the other side of this wall. They're just packing up, but there's still some material left here. So you can see how you can use different types of material. This, for example, is bamboo, very finely shaved, to make new construction materials that you have never thought about before. Here you can see the green parts. This is where bamboo is growing. And at the same time, these are the parts of the world where steel is very, very expensive or is not produced and has to be bought. And you can see how the fantastic properties of bamboo are. You can see here the tensile strength. You can see carbon is the strongest, but bamboo with 820 MPa is sometimes stronger than steel with 400 MPa. And you combine it with concrete in a way that you can see here. So that's the stock and flow of material. Very, very important. Have you taken a studio in this with Dirk Hebel? Anyone? Did you? Yeah? Okay, so you know. This is really a great example for stocks and flows. Then, of course, stocks and flows of housing, of space where people live. With Sascha Menz, this is a good example of stocks and flows of materials, mining urban stocks. You can see here all these buildings in Singapore, and you can see, although they look very stable, they're in a flow. Because over time, you just spread the time a little bit, 1846, looks like this. 1893, all new construction here. 1930s, 1970s, and 2008, you can see how even the heavy building materials are in a flow and come and go. Or here, the stocks and flows of density and space. Kees Christianse and his group made these great studies, comparative studies, in Singapore, in Shanghai, in Shenzhen, in Bangkok, and you can see how the different facades, the different density is handled in these different places. Or, if you look at a more abstract level, Christian Schmid and his group, looking at the density distribution in the world, and you can see here all these red parts, and especially this red part here in Java, which is one of the most heavily populated parts in the world. They are much more dense by now than here, the old places in Europe or in the US, East Coast, West Coast, which were the highest density places before. And stocks and flows, how you transform poverty from poverty to better situations, or stocks and flows of water here with Christophe Giraud, the power of water both in positive and negative ways, and of course the stock and flow of transportation. And this is my last simulation here with Kai Axhausen, where again, now you can already maybe read that it's a simulation. The whole city of Singapore, which I've shown you before at the beginning. Now we can understand better because each one of these little cars going around there is an agent that is simulated with a simulated behavior, and the behavior of each one of this agent going from A to B is taken out of surveys and taken out of some real measurements. And with that, you can predict certain traffic jams, and you can predict, if you make changes to the transportation system, how the overall system will work. So these are different stocks and flows in a city. They're all connected to data. And the data, as you learned in the beginning, can be generated from observations, from sensors, from measurements, or from simulations. So that's the summary. Stocks and flows are a fundamental concept to understand cities and to develop them further. Big data is part of the stocks and flows of information. In the sense of information architecture, it becomes a new raw material, because if you understand how they flow and what the parts are, you can make a new information architecture of a city, which is the name of this course. But never forget the ethical aspects of using big data that will determine its acceptance in the future. And everybody who forgets that will sooner or later be drawn to that point. So please consider it now from the very beginning. Any questions? Yes?
How accurate are those simulations? And used in the very good? Or
They are as accurate as the model is, and an amount of, or the degree of fineness of the data. So if you have this one from Singapore, for example, only every 5 years a survey of maybe 1,000 people out of 5 million is taken, how they behave, where they live, where they work, and so on. So from these thousands, we have to extrapolate to 5 million. So you can imagine it's not particularly accurate. The other part, of course, where they can move is pretty accurate because the streets are there already. But it gets more interesting if you want to simulate a future city where you don't have streets yet. So then you need the profile of the people, what they want to do, what they want to work, and then you could actually generate where the streets would be rather than the other way around. And of course, if you want it totally accurate, you would have to measure it, right? So you would have to measure every person going everywhere. You would have to interview every person at any point in time, what they're doing, what they're planning to do, where they're coming from, where they're going to, which would be theoretically possible. But I can assure you that this group is working very carefully, so they try not to do any kind of wild speculations. They do really good calibration of parts of the model with reality, and then they take the next step.
Yeah, I think I have a good example of Swiss, you know, this insurance.
Yes, Swiss Re. Yeah.
Swiss Re,
Yeah.
yes. And they did the simulation in Bangkok, and they had to destroy a dam, and then there was flooding, because they are insurances of real estate, so they could lead the flooding they led the flooding to the poorer parts of Bangkok, and like that didn't have to pay as much money as if the water would have flowed into the rich areas.
So then you can check from these 8 points I gave before, which one of those 8 points you would have violated. That is very important, and these will become very, very real. They have to become very real. At the moment, big data is really like a raw material, like anything, like sand, or you don't know really what to do with it. But it will be standardized like many other things, and at the moment you can do good things and bad things with it. But unfortunately, this example from Bangkok is really true. From Jakarta, it's also very true, and there you can actually, unfortunately, study the accuracy of your simulation every year, 2 or 3 times. When there's Ciliwung River going through the city, you just have to take the aerial picture and compare it with the simulation you do, and then you can see 1-to-1 if it's real or not, unfortunately, because it keeps happening. Yeah. Yes, there's another one.
My question is how to give the permission for the architects, as an example, to access to the data, because I think it's quite sensitive. It's quite sensitive information when if everyone can access to the data, so it will be a mess thing.
Yes. This is also a very good observation, because at the moment we have those two worlds almost. We have the data that is taken by authorities that have measured things and recorded things and keep them safe, and also keep doing a pretty good job of keeping the the personal protection of these people. So to access those data is very difficult. On the other hand, we have the data that people just not voluntarily, even without knowing, donate to the phone companies and other companies. These data are, towards the individual, not protected at all. But the companies, they have all this data, and they say we cannot release these data to the persons. So you have all kinds of conflicts of interest, of protection in that. And my prediction is it can not be solved. In every project we're doing right now in Singapore and in Zurich, we have to put down a percentage of the overall time just into collecting the data and getting access to it. Estefania, for example, for her PhD in Colombia, how much time did you spend to get to the data? Well, you generated themselves. You generated themselves because you made this app made, then this app was distributed to the people, and then the people, they knew that they would donate these data to her for her scientific work. So this is very good. This is how it should be in the future. This is how it has to be, because it's the only way that you give those data away, and you know it's you who says that. But I would say if you get any data in less than 3 months, then it's very good. And it depends over time. If you have the trust of a city or a neighborhood or something, it goes much faster. So when we started here with the chair 20 years ago, to get data was very hard. It took a year. And now, just for Danielle Kriego, for her PhD, we are down to almost 3 weeks from the time we need them until we get them.
Because for the permission issue, actually, I spent already like 4 years working with HDB in
Singapore, yes.
And personally, I don't have, even when I became like a project manager,
Yes,
I don't have any like permission to access to the,
right.
yeah, you know, like HDB, they have a lot of data, and that's why they can make it like requirement.
Right,
the,
right,
the standard guideline and everything for that.
right.
And in the end of the day, we just follow it. You know, we don't have any like permission to discuss or to.
Not yet, but that's our project in Singapore. So if you're successful, you will have more data. For the others, HDB stands for Housing Development Board, right, of Singapore, which basically does build all the housing, and 80% of all people in Singapore live in these public housing projects, and therefore this HDB is extremely important, and they have all the data. But sometimes they don't even have all the data. They have outsourced it to companies, and so these companies have the data, and to get them back is very, very hard. But it's a good example, because Singapore has a lot of data, very exact data, hard to access. Other countries like Jakarta have no data, almost no data protection, so you have to generate them yourself, and then you can use them for simulations. But it's also not a good simulation, and a good situation. Okay, so I'm sorry, you will be followed by this big data question for all of your careers, I can guarantee you. And the earlier you understand how they are made, where they come from, what they mean, the better it is. And architects designers are the last, hopefully, positive data creators, because with your designs, you generate new data, because when you do a drawing or you do a 3D model of your design, you generate data. And in this data world, into this architecture or this information architecture, then you bring in your clients, when you walk them through your 3D representation of your building. This is the data you have created, only you. And it's your copyright. And this is good. This is how it should be. Okay, very good. So see you next Monday. Thank you.